Okay, so today we'll continue with our topic, which is internal flows and CFD using SolidWorks flow simulation. They are very good tutorials. So what I would say, I'll start with SolidWorks. Here we installed that SolidWorks 25. So search for SolidWorks 25. I think the ITS, they did install them on these computers now. And if you're using these computers or using your personal laptop or computer.
Our license is still 2024, is it? For the...
Yeah, they have different licenses here. They use this one, the one I'm running is the Education Edition Teaching. The one you have is the student license. Now, again, the challenge of it, if you use the 25, you must keep using the 25. So you cannot work a bit here on your computer, on the winter computer, and then you take it back to your laptop. So stick with the version you're working with. I think only Shivam did install the 25. Have you, Zia, installed 25 or 24? 24, yeah, Shivam. If you want to give it a try, install the 25 using the same code, and because it may work. Yeah, give it a try, but don't delete, install. And if it doesn't work, then stay with the 25. So make use of these licenses like that. And then after we will go some of the examples today, because there is an example. We'll take a bit of time today, but it's very important because it's very relevant to your assignment, which we'll talk about it, assignment 2. So again, you need to start the parts to make sure like you cannot go to the add-ins before there is a parts. I feel like 25 is slower than things. Okay, so for me it's already activated, but if it's for you was not activated, I'll just bring this screen here. You always come to the add-ins, and from that kind of like a gearbox, options and add-ins, and from the add-ins you need to click the SolidWorks flow simulation from both sides. Because I don't need to use this one and not this one, I will always untick them for me, especially I'm not doing any routing at this stage. Or maybe we would show you some routing because routing is internal flow. I untick them because just to reduce on the computer itself, because this winter computer is 5 years, actually 7 years old, this computer. Even it's running really, it's a design for workstation for simulation, but the RAM and everything in the processor. So for me, I always untick them just to remove that from the processor. And then you can see the flow simulation itself, it's moved here. So how to go to the tutorials provided by SolidWorks simulation, you go to the help. From the help, you go to tutorials, you go to SolidWorks simulations. And remember, that tutorials, it's only if you're going to FEA. We don't want the FEA, we want to go to the flow simulation tutorials. So kind of like the software, if it's only simulation is FEA. If you read the flow, it's mean the flow simulation, which is the CFD. CFD stands for computational fluid dynamics. So the movement of the fluid using computational tools such as, so you click flow simulation tutorials. And then from that list, you have the first steps. You did the ball valve. We would do today the conjugate heat transfer. And then we select, because conjugate heat transfer is internal flow, and then we possibly go to that example, which is relevant to the assignments, is determining of hydraulic loss, which is intermediate. I don't think you've done this last week, have you?
Yeah, I think we did. That was the...
Oh, you did that one, yeah. Okay, then if you've done that one, then that's fine. No, there's two differences. There is those valve.
No, we did the hydraulics.
You did the hydraulics because that is the valve as well. So they're kind of different things. But if you did the hydraulic, then that's very good. Heat exchanger is the one I want you to do today to start. Then let's start with the heat exchanger. So how can we find the heat exchanger? So let's minimize this, minimize this. So you go to intermediate examples, heat exchanger. How can I find the heat exchanger files materials? Because we don't want to spend time on developing the product itself or the heat exchanger. We want it straightforward to go and find the files. So you go to your C drive, Windows. Under that, remember, we say program files. Under program files, you go SolidWorks. Have they removed it, changed it? Ah, that one, SolidWorks Probe. And then from SolidWorks, you go SolidWorks Flow Simulation, and then you go to examples. And then you can see based on it, either you read the title or it's B3 because it's tutorial B3. As you can see it here in the website, it say copy the B3 heat exchanger folder into your working directory. So that is recommended because many of our computers, especially if it's admin restrictions, you will not be able to modify things under the C drive. So I will copy that file, the B3 heat exchanger. And for me, because I'm working now on desktop, this is not my personal computer. And I put it here, and then I will go to my SolidWorks file, and then File, Open. I go to Desktop, B3 Heat Exchanger, and then which one do we open? We don't open the parts, we search for the assembly, okay? Because remember, parts, they create an assembly. So task is called. And then you open that as an assembly. Okay, I will split my screen to two sides. I don't need that library material, so I can just unpin it and minimize that size at this stage. I don't need that much of space. I always like to keep my apply scenes to plain white so I can see things nicely. And I bring the website we opened the tutorial, and I bring that one, I close that, I don't need that, I just need the tutorial itself. So now I have kind of like two screens, one where is my model, one where is the description. So basically, if we describe this model, you have two fluids going through this. The first fluid is air, so we're mixing two different types of fluids. Air is coming from that direction. I'm assuming it's going Z, or I need to check my coordinates. So that is very important. We will see to how it's described. And then leaving from that direction, but enters with hot air at 10 meters per second, the velocity of the air, with temperature at inlet is 600 kelvins, and leaving with whatever temperature, we don't know because we leave after the mix. We need to find that temperature. And then the cold water comes from the other, close to the other outlet of the air, which is called the inlet of the water, with cold water, 0.02 kgs per second, which is the mass flow rate. Here is good to show you can apply mass flow rate as inlet and velocity as inlet. Temperature is room temperature, 293, which is about 20 degrees, or in that case, it's 293.2 Kelvin. And then we'll come out from that as a warm water, but we don't know the temperature. That's what we want to determine at the end. And it's telling you the type of materials used here is steel, because you need that coefficient for the material properties. And then you go through it. So for you, is just follow the steps. Read the instructions, is very important, and then start following them step by step. And if you have any questions, I can, like if you're online, share your screen with me, or if you're here, I'm going around you. I'll pause the recording because this would just be you doing it. So I don't want this to be going through it. I was sharing the screen, but I want to pause. More pause recording. If you have any questions, please feel free to ask.
Where do you find the website?
So you come to that question mark here. Do you see that?
Yeah.
Help. And then SolidWorks simulations. And then you go flow simulation tutorials. That's step one. Okay. I'll click on it. Now you go to intermediate examples and you
I
see
found
heat
it.
exchanger efficiency, right?
They
Have you got it there, or do you want to share your screen? Maybe I have different
no,
versions.
I've got it.
Oh, you got it. Okay. Using the 24 or 25 SolidWorks version?
24.
Should be the same. I don't think will be much difference. Yeah. By the way, if you want to keep that file, all of it, you can just view document in PDF and you can save it PDF. Do you see that one? So heat exchanger efficiency, PDF it, and then that way you can save the PDF. You don't need every time to go and find it, but you get a big, huge PDF file with all the documents. You just save it on your desktop. I'll call it CFD. And that way it will save you from every time you go to the website if you want to work offline. And then you come to the contents here and intermediate, you have three examples, heat exchanger, close that, and you work with it. And it's the PDF, I find it for me is better, more organized than the online.
Or you can save it to the bookmark by clicking
Yeah,
that
bookmark
star.
here. Yeah, you can do a lot of things. So it's up to you. But if you want to really just PDF and you go through it, it's your options. Like choose whatever makes the best for you. Okay, so while you're working on that, I'll find you the example for the Pascal. So I'll stop sharing now. MG6039. Assignment. So I will talk about the assignment, the common one. So now assignment 2, if we go through it, so again, this is the assignment 2 will be due on the 29th of April. I'll tell you about that date. You go to welcome. From the welcome, you download the course outline. And from the course outline, you will search for that assignment. You can start working on it now because it's covering internal flow. It's not our external flow. So under that, you will come to the assessment sections. I'll go through it. Assessment 2, CFD analysis of plant section. So it's 29th of April, 11 p.m. report SolWorks files, everything. So you zip everything for SolWorks and please attach the results of that. It's very important because we'll save time to investigate everything. AI is not allowed. So introduction. The aim of this assignment is to demonstrate your ability to use CFD software packages and compare results with empirical calculations. The first one was comparing results to experimental data. Now you do calculations. We need to go and revisit fluid mechanics. So you will simulate the flow of water through a section of pipe containing different features. You will compare the head loss due to friction and minor losses in the system from the CFD model and calculate using Bernoulli's equation and discuss reasons for any differences between them. So using SolWorks model of the assembly, create CFD analysis. There is a folder on Moodle, which I'll show you later, as containing a zip file, has that SolWorks file. So I'm giving you the SolWorks file. You don't need to redesign. Assembly. You run 2 analyses. Remember, in fluid mechanics, especially related to Bernoulli's equation, you have Reynolds number who decide if the flow is laminar or turbulent. If flow less than 2000, Reynolds number is dimensionless value, no units, it's laminar. If it's bigger than 4,000 is actually turbulence. But I want you to model it's bigger than 10,000. So it definitely is well-developed flow regime turbulent. Assume the pipe has a roughness of 0.05 millimeters. So in the past, we used to know the galvanized pipe or the material properties, you select the roughness. Create appropriate goals to allow you to calculate the total head loss in the system due to the friction, HF, and minor losses. So that is the total losses in the system, HF plus H algebraic summation. So what we have, friction losses due to the friction of the length of the pipe, plus the minor fittings. And that could be an elbow, a valve, or whatever things with it, equals to what? The pressure difference between the inlet and outlet divided by specific weight, which is gamma rho g, density times gravity acceleration, plus the kinetic, or we call it the kinetic head loss, which is the V1 square minus V2 square over 2G. For each flow regime, so for the first one, and then the second one, you repeat, record and visualize the results of CFD. So first you set up your velocity. So now I'm giving you the Reynolds number. You need to think about the velocity. You calculate the diameter. You reverse the equations. Reynolds numbers equals what? Rho VD over mu. You have Reynolds. You set it, for example, 2,100. Or sorry, less than 2,000. Let's set it 1,000. Rho, what is the fluid here? Have they mentioned the fluid? Water. So I know the density for water. I know the dynamic viscosity for water. What I will find? The velocity of the water at Reynolds number less than 2,000. And I repeat the same thing, the velocity for Reynolds number bigger than 10,000. So you could choose the value 10,100, just slightly bigger. Compare and discuss the result. You do the same thing for calculations and with the CFD. The calculations follow this equation. V squared over 2G. F is the friction loss you find from Moody chart. L is the length of the pipe. D is the diameter of the pipe, plus summations of all those minor fittings. I just define them. For laminar, the friction factor, F is equal 64 over Reynolds. For turbulent, friction factor using this equation. That if you don't want to use Moody chart, you can do that in Excel file. Technically, you embed this equation in Excel file, it calculates for you straightforward value because relative roughness, E, is given 0.05. E is the pipe roughness. Use Excel to do the calculations. Use best practice to present your calculations. You're required to write a report. Again, the report limit to 1,000 words, excluding references and appendices, okay? You have a lot of results. That's something we need to talk about. You push things to appendices. You don't need to duplicate some of the tables and stuff. See marking schedule, rubric for each criteria, and report writing guidelines, and upload everything to Moodle. This is the marking. Follow the instructions, introduction, method. Of course, you need cover page, title, your name, your course, and everything. Content you need, that's part of the report, is very well, nice, organized. You have an introduction, method. You have two things. One is the calculation, and second one is the CFD. Results, you discuss both results, this calculation and CFD, and you compare between the calculations and the CFD. And then you have a proper report. Excel files presented, you must show Excel files for your calculations. So you don't do handwriting calculations, use Excel files. We will do, next week we'll start using Excel files to do something in engineering is used for FEA and as well CFD. Complete Moodle lessons, those lessons we do here, you get really post and repost on forums. That's the assignment. So where can I find the files for it? You come back here, you go to assignment file where you upload everything. You click on the plant zip file. This file, extract all. You must extract it all because SolidWorks will not like to work with something if it's zipped file. I just don't need that. I don't need that at this stage. File, open. I go to my download. That's what I'm using at the moment. Plant. Search for what? Before we search, see the elbows. They are labeled here. You have 45 band, 90 band, and you have diffuser, balls, lid, and everything set. So I will select that one here. Is the plant, which is the assembly, and you get a nice structure here. I always go to my scenic and make it plain white. So that is my system. If I want to see through things, maybe that one is the best. So technically, this is the cross section from the top. You can see the valve. You can see the elbow. And you can see another elbow. And you can see a diffuser there going through.
Flow is it? Is it coming out of the diffuser?
It should be coming out from the diffuser, yeah. That it's something we don't answer it, yeah. Like the flow comes here, goes that way, yeah. So because that's how the process for this application. And the valve is before because you want to lock it or close it. If I look carefully here, you can see how the valve, how much is open. That actually is the coefficients you need to determine, similar to the tutorial I told you before. So before you start working on this assignment, this is a hint for you. You go to help SolidWorks simulations, you go flow simulation tutorials. The best one to start with is the one I mentioned, intermediate, determine hydraulic loss. That tutorial, it's a good start. Will help you a lot. Now that is simple. It's not identical to what you'll be doing in the assignment, but when you learn things here, will help you to understand how can you set up the system, because your boundary conditions will not be the valve, will be far away from the valve. We're talking about inlet and outlets. And what you have always, your inlet is inlet velocity. Who decide on your inlet velocity? It's your Reynolds number. So less than 2000, choose a value. You know the diameter. How can I find the diameter? It was given. But if I want to check the diameter, you need that circle. That's your inlet diameter. Reynolds equals what? Rho VD over mu. Rho for water, mu for water are constants. Reynolds. There is a way you can use equations, goals, to calculate even the velocity. So you can use SolidWorks to be the calculator because you don't need to perform that. SolidWorks by itself, if you have define the densities and viscosity, it can give you the velocity, the one you want to calculate. So that is you decide based on that. It's given the diameter, I think was given, roughness is given, and then that one you measure. So everything is measurable. It's not like something you can use the evaluate tool, measure and mark up, and you can go through it. Temperature is not included in this example. It's one room temperature, so we don't have problems about temperature. It's just internal flow. The funny thing, it's your boundary condition is not on the straight. It's going right and left. So it's following different directions. So when you create the computational domain, you need to make sure that this boundary condition is included and the other one there is also included. So you'll have covering them nicely. And you can see flow comes that way, let's say, goes that way, and then goes that way, and then leaves from that direction. So you'll have a nice go through it. So the tutorial I did for you for a straight pipe is helpful. The tutorial you did for the valve, the one, if you haven't done it, please revisit and redo it again before you start with it, because it's designed to make you to calculate the head loss. So you say, how can I determine the head loss for this type of applications? That tutorial, it's called determining of head loss. It's exactly what you need to learn today from it. Like, it's very good. Total pressure loss. It will show you how can you find it, how can you set it up, and then how can you find the drag. Technically, what we're trying to say about this topic, this is actually the equation, which is, it's calculated for you. I was talking about Reynolds number, rho u d over mu. That drag coefficient is actually, SolidWorks calculates for you the K value. So you know the K value, what used to be given to you in fluid mechanics exam or test? They go to the tables and you find the minor fittings for the valve. SolidWorks will do it for you using that equation. Technically, that equation is very helpful for you. Set it up under goals equations, and then you go through it. Sorry, I went to another tutorial, not that one. No, I'm going to the other tutorial. No. It's here. Where is that? Drag. I'm talking about that one. Now, the other one is external flow. It's also useful, but for different things. Yeah, that is selecting 40-degree long valve, and then from it, you can determine what is exactly the loss from it, and it can give you the exact value for it. Should be, yeah, that one. That's the value. You can get the pressure, average value, minimum. And then, yeah, total pressure loss in the system. You add a new formula, and then you get from that exactly how much is the drag coefficients for the application. You set up the density I was talking about, the values there, you find total pressure, kind of like you're solving the P2 minus P1 over gamma, which is rho G. And then you set up that one. Pure local drag. And then cloning, changing geometry resolution. And then that is actually the local drag. That is actually what they found. Total pressure loss is that value. and the local drag. So that is actually the K value was impacting based on that scenario. For some reason, I click very quickly. That is a different setup. That is a cylinder. The air goes on top of it. This example, you do it after the break. This is important if you want to study the drag on airplane, drag on a racing car, drag on the spoiler of a racing car. So that is also another good tutorial on how can you set up the equations in the equation goals for it. So it's just you do it hopefully after the mid break. But the most important for you, do that tutorial definitely. And before that tutorial as well, do from the first steps, there's another tutorial, the ball valve design, as well as very good tutorial. It's showing you how to set up the boundary conditions in step by step. I thought like you did that one last week. I think many of you did this one last week.
I did the wrong one. Pretty sure I
Yeah.
did the hydraulic.
You did the hydraulics. No, I think some of them, they did this one. Yeah. With the line.
Oh,
Yeah,
okay.
you did that
wasn't-
one. I don't think you did that. Yeah.
You're right.
Yeah. They are different valves. That's why I'm thinking you haven't done. So you have 1 hour. Start now with this tutorials, which is determining hydraulic loss. So again, how can I find the file? You go to C and you go through it, because this one, it's different valves. See, the valves are not same.
Yeah.
It's different valve. That's why I remember it is recorded on the video. So do this one, because this is very helpful for your assignment. Again, it's not identical because you need to think, learn, think, apply on your assignments. Okay. Is it good for the people online? So please, if you can do the intermediate example, determination of hydraulic loss. Or we call it local, how to can find the local drag for a valve. How can I find the file? For especially, you go to, again, I'll show you this again. You go to this PC, Windows, Program Files, just search for SolidWorks Corp, and then from SolidWorks Corp, go to SolidWorks Flow Simulation, Examples, and then search for that exercise, which you will see it's called hydraulic loss. That one, B1. You copy it, and then you work on it. I will copy it on my desktop. I'll delete this later. So when I come here, File, Open, Desktop, Hydraulic, the valve, and then you get that valve. Work in 2 screens. One is here, the other one is here, and then start working on this one. Okay, so that is definitely very useful to start with to think about processing. Okay, I'll pause the recording. So just follow it. It's a good example, as I mentioned, for your assignment too. And it should be. Now, something I haven't mentioned for you, but I will say it now. When you go to that tutorials, remember, for example, you will see 2 files. One is called valve, the other one is ready. When you click on the ready, it means they already set up everything for you in advance. And that is just run. So when you go to the ready, you find these already set up for you. The only things you need to do is just to run the results for you to find them. It's just to make life easy for people, because remember, these are for learning, for practicing. So if you say, hey, I'm not getting the results, go to the ready and compare what you done, what you missed, because you can relearn from it, reverse engineer it, and go through it. So here I'm running just the ready ones. They already designed earlier advanced for it. So that is something helpful for you. Now, sometimes in the ready, you're using a version developed, an old version using 25, you see slightly difference between them. That something could happen, but in general, they are almost the same. Yeah, and now you can see the result for that one. Show, if I want to show the results, remember always you click here and hide the geometry. You can see how it's coming nicely when it's the valve fully open, because it's 0 degree long valve. Okay, so the results for the 40 degree, because I run it here, I don't need to rerun again. You come here and just say load results, cut, plot, show it. This is where 40 degrees. And I go for the another one 40 degrees short, load results, and then cut, show, and I can see it for the short valve. So it's very useful here. Short valve, long valve to different degrees, because very good on how you set up things. Those total pressure 1 and total pressure 2 goals are very useful on how you set up goals for assignment. Definitely I will go and see the other tutorials is about the cylindrical drag coefficient. That tutorial, I know it's for external flow, but these tutorials help you to set different Reynolds numbers. And also, how can you set up an equation goal to calculate the drag coefficients? So that is also a very helpful tutorial. You do it hopefully after the break. But if you want to start with it, definitely just give it a try. When you have time, you can learn another topics. I will look for something advanced examples. I want something internal flows. There are not many internal flows. Like when you read the specification, you need to find something that says this is internal flow analysis. Internal, this one. So when you have time, you can do the non-Newtonian flow in a channel with cylinders. That's internal flow in the cylinders. Another one, it's also internal flow, is the porous media, which is very, when you have a filtration system. It's also internal flow. Right, so that's all for today's session. I will close the Zoom and then upload that video. But do you have any questions, the people online?
Nope.
Yeah, I'm good, thanks.
All right, take care, guys. And
See-
please update me
ya.
about Josiah, please. I need to know about Josiah. I emailed him, but nothing. If you see him,
Try.
and or, yeah. Take care. Bye.
Will do. Thanks. Bye.
Thank you.